So when forces are in equilibrium, what's the sum of all the forces equal to?
0.
0. Yeah. We're just talking about adding sums and of forces, and they add up to 0. A lot of zeros. Everything comes to 0, so it's kind of nice. So another thing too is the forces can be broken up into their. Okay, so the forces can be broken up into their components. So if we had boxes. Yeah, we're recording. If we had F, it can be broken up into Fx and Fy. So then going back to the equilibrium, the sum of my Fx would equal to 0. Well, not here, not for this picture, just when we're looking at equilibrium.
Okay. Equilibrium is the little 3. So that's sum.
Sum. That's sum of all forces. And sum of Fy would be 0. No big deal. It's like it's already on the board. Okay, we'll just look at a little quick example. So if I had a force in the x direction of 3 newtons, and in the y direction of 4 newtons, what would the equilibriant be for that? The equilibriant is the force that makes everything balance. Well, which direction would it be? Down that way, right? Well, it'd be 5, but how do we? Well, okay, how do we? What's the sum of the F in the y direction have to equal?
4.
For it to be in equilibrium, what's the sum? 0. That's easy, right? So what forces would we have? We know that we have some kind of force here, right? So we have 4 positive plus, we'll just call that F. Fy equals 0. Pretty easy. So then Fy equals -4, right? Algebra. Same thing in the x. What's the sum of the x forces equal to? 0.
3 plus Fx equals 0.
Well, this time it's going to be a -3.
What? Oh,
because it's in the left.
okay. 3 plus 3.
Plus Fx equals 0. Fx equals 3. How do we get 5 from that? Oop. So we got 4 down and 3 over. Right? Oops. That's got to actually go over here like that.
How do you know, Gus? Yeah, how do you know? Just because of the direction. Oh, yeah, because that one, this was just.
Yeah.
Hey, again. Go. Use a glue shit. No, I don't know. Just come.
So
That's a piece of French stuff.
yeah, okay. So Fy is -4. Fx is +3. We're looking for F. So yeah, a squared plus b squared equals.
I actually got that right.
25 square root, and F equals 5. We won't worry about direction right now on this question. No different than what you guys done before. It's just everything equals to 0. 0. Okay. Next. Let's look at the example we looked at the other day.
Oh, why is there a car? That doesn't make any sense. So this sort of protractor. Why is there two of them? Okay,
It's
what's going on here?
okay. I'll explain to the two boys that were away at basketball what's going on here. So we have a pole that's going
Pole's going up, down.
up and down, right? It's got a string attached to it, going like that, and there's a weight at the end of the string that pulls down,
Oh, wait.
like,
Oh,
okay? The weight pulls down, straight down. This is all in the notes too, by the way, guys,
what notes? I didn't know.
on the internet.
Oh, okay, let's keep going.
Okay, we'll keep going.
Force weight 300 newtons, so it's like
300 newtons.
find the mass of the weight. No, it's not.
Okay, so force weight 300 newtons going down.
Uh-huh.
So because there's a string on both sides, this FT1Y, the tension on this wire in the Y direction is 150 newtons, half of the weight that's being pulled down, right? No big deal yet?
There's two ropes acting on the 300 newtons, so each rope gets half of it.
Yeah, each rope gets that.
You know, rope like this.
Did you draw that
And
one
then,
before?
no, I'm holding up the rope.
Yeah.
Half of it goes here. This side.
Use like a.
You just have it on.
Okay,
Where's the other?
We're-
Under the side of the rope.
we're not worried about the other side right now. All we're worried about is what's the force on this wire right here, this tension line.
Who cares about the opposite wire?
Well, that's the force that keeps the pole from falling over, Doctor.
Oh.
Oh, there we go. Okay, so first we need to find the sum of the forces in the x direction equals 0 because we don't want it falling over this way. So what forces do we have? We have Ft1x, Ft2x.
Okay. Detention. So they're both 0.
They're not both 0.
Equal 0.
First, let's find this one. We know the angle, we know the weight.
Oh, that's just like.
So then easy, we find out using trig
Okay.
what that one is.
So why is it negative?
Why is it negative? Because it's in the left direction.
Okay, that answer is for what?
This?
F1x. Oh,
It's for right there.
Okay.
Okay?
Yep.
With me so far?
Yeah.
And then we solve for this one right here because everything's equal to 0.
Okay.
French toast.
No surprise.
Right, so to speak. Really?
We're gonna eat it.
Thanks. So now we need to find FT2, tension on our guy wire. We have this one, and we know our angle. So using trig, we find it's 2,000 minus 2,488 newtons.
Someone else. So since F1x or whatever is that, you just assume that F2x is that?
Because
F0?
we can assume that it's, well, we don't have to assume anything. All we know is that the sum of the F0 is 0.
So one is E5 and the other half E.
But it depends how many forces you have. If you have 10 forces, then F1 plus F2 plus F3 plus whatever 0 equals to 0. They're all going out of 0.
Okay, so 85 plus minus 85 is 0.
Yeah, if we have that, yeah.
Okay.
Okay. One thing that we can talk about with you guys is a tension is when it's a stretch or a pulling force, the molecules are being pulled apart. And we didn't talk about on Thursday was what do you think compression is?
Okay.
Pushing them all together.
Pushing the molecules
We can't
together.
push ropes together. Oh, we had this argument last year.
We did. We can't push the rope together, but that's okay. We
had
can push the pole. The pole can be compressed, right?
Yeah. Holy shit. I forgot about that. Okay, go on. Mind going. You can't compress a rope.
Okay.
Just stop
Okay.
recording.
We have compression on the pole because there's this force pulling down this force pulling down, gravity pulling down on the pole, and there's a normal force pulling up. Right? What's pulling up? There's normal force pushing up on it. It's opposite, right? So let's solve for our normal force. So we have sum of F in our y direction equals to 0. The pole's not moving anywhere. Pretty easy. So we just add up our forces. We have our F tension 1 in the y plus our F tension 2 in the y plus FW plus Fn equals 0. It's all equal to 0. Okay? So our first one, Ft1y is equal to minus 150 newtons. It's given. Because it's half the weight of the lights. Ft2y, we have to solve for it. Okay, I'll just go on a new page here. So we know using our triangle, this is 70 degrees. We know this one is, where is that? 851 newtons in that direction, and we're looking for that one, Ft2y. So we have opposite, adjacent, use tan, 70 degrees, oops. Ft2y over 851, and Ft2y equals to what? Yeah.
906.
It should be cross multiply these, eh? Yeah. 2,338 newtons. That's negative because it's going down. Got that, Stefan? Okay, so we have this one is minus 2,338 newtons. Our weight I have given is 1,000 newtons. It's in the negative direction because it's down. Zero. 3,488 newtons. Good job, Stefan. No big deal. That's a lot of normal force. That's keeping that pole from going in the ground. And that's the compression on it. So,
Like this way?
yeah, compression. Because tension is being pulled apart. Compression,
Oh, so it's pushing it back in.
compression, you have force going down and force pushing up. So it's being compressed. Okay? This would be our Fn here. Okay? One more question, one more example. If you guys go to page 267. That's it. That's like a spring. It acts like a spring that Kx, F equals Kx.
That doesn't mean it's compressing.
No, that doesn't mean it's compressing, no. So it says that 10-kilogram flower pot is suspended from the end of a horizontal strut by a cable attached at 30 degrees above the horizontal, as shown in the figure. If the strut has no mass, find the tension in the cable. We're just ignoring its mass for right now. That's kind of factored in. So we have our flower pot here, nice little flower, and that's got a mass of 10 kg. And there's our cable. We're looking for FT. Okay. So we have to find what the force on the mass is. FW equals MA equals 10 times 9.8.
9.8.
Equals 98 newtons, minus 98 newtons.
What's that line underneath? Why isn't there? It's just you completing the triangle, or is that like
That's the pole.
a pole there?
There's a pole there. Look at your picture. Okay. So now we have to look at the sum of our forces. Are we looking at the x or the y? Sum of f x or sum of fy? It's sigma. It's like a. I can't draw it very well on the thing. It means the sum of all the things. Yeah. Well, which way is the pot pulling?
Down.
Down. So we're looking in the y direction.
Not even zero.
Sum of fy equals 0. Yeah. Good stuff. So what? It'd be 0. 0 is 0. So what forces do we have acting in the y direction?
Gravity.
Our FW and what else?
The weight of the flower.
That's FW.
Damn it. That's for gravity.
Well-
But there's two types of gravity. There's gravity on the wall, is it not?
No, we're not looking at.
No. What the hell is it?
This tension's at an angle. Can it be broken down into components? Sure. So it'd have one going like that. Or actually, have one going like that. Yeah, up. And one going like that. Yeah. This one here should actually be. It should actually be going like this.
Holy man.
Holy. How do I know that?
Yeah, how do you know?
Because it's pulling like that.
Okay.
It's keeping
And then the other rod.
the pot's going down, so it's got to keep the pot from falling down. Okay. So our components are FTY and FTX. So we're just looking at FTY. Equals 0. So minus 98 plus FTY equals 0. What's FTY?
Is that positive or negative?
It'd be positive 98. No big deal. Now we gotta find the tension. one thing I didn't mention to you guys. Why didn't we divide the pot's weight in half? There's only one string acting on it. Yeah. When we had two strings acting on the pole, on the lace, we had to divide it in half because each string pulls with half. Okay? Okay, so we have this one and we're searching for that one. So opposite hypotenuse, that's sine. Sine of 30 equals FTY over FT. Sine of 30 equals 98 over FT.
Oh,
98 over sine 30.
is FT like the resultant one?
Yeah, FT is
Oh, okay. Fine.
this one right
You
here.
want the X then?
We don't need our X for yet. Not yet.
Yeah.
Not yet.
Oh, shoot.
So then if you use your calculator, you get 196 newtons. No big deal. Yeah, pretty much. What that question is saying is how much compression is there on this? So to keep the pot from going this way, the strut has to push that way, right? So first we have to find FTX. FTX equal to. Actually, I did that sort of backwards. Should say it like this. We have cos 30 equals adjacent over hypotenuse. FTX equals 170? 170 newtons. Okay, so, and that would be negative. That's the cable pulling, this cable pulling this way.
So for these questions, like,
Now where do we go from here?
where we go?
Yeah, what do we do now?
We're just learn.
We're trying to find what force this bar has to press this way to keep the pot from falling into the wall.
Some of your FX has to be 0, right?
Yes, it's 170.
It'll be 170.
Sum of fx has to equal 0. Yeah, pretty easy. Oop. Sum of fx equals 0. We have ftx, and the compression force on the struts we'll just call F strut.
X. Negative 170. Huh?
Negative 170. F strut equals 0. And the force on the strut has to push with is 170 newtons. Pretty easy. Okay. Get you guys to do for homework. Practice work. Okay.
Oh, here oh.
Just wait 1 second, Steph. Okay, do questions
23.
1 to 11 on these problem things. I got it right here.
Oh, crash, ball, ball.